Hello everyone. So here we have a topic, influence line diagram. We will see this topic. First we will go by the name influence. Influence means influence of one factor, that is load, over other factor, that is response. So in case of a bridge, simply supported bridge, you have a vehicular load which is moving from extreme left to extreme right or vice versa. Okay, so for that vehicular load you have to find static response. Okay, so this load is a influencing factor. So in this context we are taking it as unit concentrated load. Influencing factor is a unit concentrated load and the influenced factor is the static response. Static response means the support reaction, shear force at any point between the bridge and bending moment at any point. So what is our aim? To this moving vehicular load, which is influencing factor, we have to find the influenced factor, that is static response, maybe support reaction, shear force and bending moment. In case of bridge design, our aim is to find maximum responses. So we have to find maximum responses, maximum response of support reaction, shear force at point C. C is any point between A and B, and bending moment at C. So how we are going to find this? We have a vehicular load which is moving from extreme left end to extreme right end. To this moving vehicular load, we have to identify the spatial location of unit concentrated load or vehicular load so as to get maximum responses such as support reaction, shear force at C and bending moment at C. Now let's look, let us define influence line. An ILD, influence line diagram, is a graph which depicts the variation of a particular force responses. Particular force responses, it may be support reaction, shear force at C, bending moment at C, for different position of unit concentrated load on the span of the structure. So at every position this unit load is moving from A to B. At every position we have to determine the response of RA, RB, shear force at C and bending moment at C. It's a graphical representation of the various force response for the vehicular load which is moving from extreme left end to extreme right end or vice versa. Now we will see uses of influence line diagram. First is to identify location of moving load, vehicular load, that would result in the maximum values of support reaction and internal force resultant. Means this means shear force and bending moment. So this load is moving from A to B. We have to find the location of 1 kilonewton so that we will get maximum RA, maximum RB, maximum shear force at C, maximum bending moment at C, because this load is moving and we don't know at what location we will get RA, maximum RB, maximum bending moment. So by using influence line diagram we can easily identify the location of the moving load so as to get maximum responses. Okay, and the next use of this influence line diagram is it enable us a quick calculation of these force responses under any loading configuration. So in this case you have a simply supported beam and there are multiple loads. Various loads are given: UDL, uniformly varying load, multiple point loads, and it will be a difficult if we go by classical method to find support reaction. Classical method means by using equations of equilibrium. It will be difficult. you have to crack many equations. But when you have influence line diagram, ILD, it is a quick calculation. It will enable a quick calculation as compared to the usage of equations of equilibrium. You can easily find RA. When you know the influence line diagram for RA, you can easily find shear force at point C, bending moment at point C, easily find RB by using influence line diagram as against the usage of equations of equilibrium.